Hello, everybody. Miss Luris here, and we are starting a brand new chapter, Chapter 6 Energy and Machines. Now, unfortunately, this chapter was going to be chock full of labs, but I'm going to try to have you guys do some labs at home and maybe some virtual labs. So I'll have to plan for that. But for now, we are going to learn about kinetic energy. Okay. So, energy is the ability to cause change, any kind of change. It could be movement, it could be a change in color, it could be a change in temperature, it could be a change in anything, pretty much. For example, breaking a window into small pieces. You're changing the window from being one piece into a bunch of pieces. Converting food into usable particles for your body. So, converting food into like energy that you could use. Tearing a sheet of paper in half. Something as simple as tearing a sheet of paper in half is energy. It's causing change. There are different forms of energy, though, which can be converted from one form to another. There are a bunch of different types of energy, and you're going to hear about conservation of energy, just like conservation of mass, conservation of charge. You're going to hear about conservation of energy a little later in the chapter. But just know that energy can't be created or destroyed, but it can be converted from one form to another. So kinetic energy is the energy of movement, of motion. If you're moving, that means you have kinetic energy. You have to be moving, though. You can't be sitting still and think that you have kinetic energy. So this little boy that's jumping up and down, he has kinetic energy because he's moving. So kinetic energy is just like any other kind of unit, not unit, but any other kind of measurement that we talk about in science, just like force, acceleration, velocity, stuff like that. So there's a formula that goes with it. I'm sure you guys are thrilled to hear that. Now, this formula is a little bit more complicated than like F equals ma. It does depend on mass and velocity, so those are the only two things that you need to know, but it is a little bit more involved. So the formula is kinetic energy equals 1/2 times mass times velocity squared. So you need to be able to do like order of operations. You need to square the velocity first because exponents come first, right? In PEMDAS, parentheses, exponents. So exponents have to come first. And then you can multiply from left to right. So energy is always measured in joules. I know we talked a little bit about joules in a prior chapter, but energy is measured in joules and it's just a capital J. So for example, if you're talking about kinetic energy and you're saying that, someone walking has the kinetic energy of 5 joules, you have to make sure that you put the J at the end. Now this YouTube clip video, I am going to post on Google Classroom. I'm not going to play it here because you won't be able to pick up the audio very well, but it's just a very quick YouTube video, just a couple minutes, and it explains what kinetic energy is. So we're going to practice. So what is the kinetic energy of a 75 kilogram person on a bike traveling at a velocity of 800 meters per second? So for the kinetic energy formula, it's 1/2 times mass times volume squared, velocity squared. So we need mass and we need velocity. Now let's look over here. We should know that kg always means mass. So we know the mass is 75. And it says right here our velocity is 800 meters per second. So we know our mass and we know our velocity. We just have to plug it right into the formula. So we have a mass of 75 and a velocity of 800. So we would do 1/2 or 0.5, however you want to do it, times 75 times 800 squared. You'd have to square 800 first. So here we have 1/2 times 75 times 800 squared. We square 800 here. We half 75, and you multiply those together, and it is 24 million joules. Okay, so let's think. Let's do another one. I'm going to pause you guys for a second, and I'm going to pull up something that I could draw on. Hold on. Okay, we are on Notepad. Very, very basic. But I am going to draw the formula first. So it's kinetic energy equals 1/2 times mass, whoa, this is bad, times velocity squared. Okay. So let's say we have a cat, because I'm looking at one right now. We have a cat, and the cat is 5 kilograms, and it's moving at a velocity of 10 meters per second, which is very fast for a cat. Okay, so our mass is going to be 5 kilograms. And our velocity is going to be 10 meters per second. So we're going to put that into our formula. So we have half, but you guys know that half equals 0.5. So it might be easier for you guys to put that in your calculator. So I'm going to do it like that. I'm going to do 0.5 times 5 kilograms times 10 squared. Okay, so we do the 10 squared first. So let's bring that down here. 0.5 times 5, and 10 squared is 100. Good. I'm saying good. Okay. So then you multiply all of these. And we're going to go down to our trusty calculator. And we're going to do 0.5 times 5 times 100, 250. All right. So our answer is 250. Now, are we done here? I hope you guys are saying no. And what do we need? We need our unit. So our unit would be J, joules. Okay, 250 joules. Now, that's it for today. Let me go back to our PowerPoint. All right. That's it for today. You guys are going to be practicing this calculating kinetic energy. You also have a do now, which you're going to have to do. So if you need help, please let me know. I will be available by email. And if you want a video chat, that's fine. Just let me know. All right. Bye.